Number one, a ball of mass 2.7 gram is released from rest from a height of 20 meters above horizontal ground. Show that in the absence of air resistance, the ball impacts the ground with a speed of about 23 meters per second. When the ball in this position, this ball has potential energy with formula m times g times h. When this ball hits this ground, it has kinetic energy with formula half mv squared. According to conservations of mechanical energy, it says that uh, potential energy equal kinetic energy on this phenomenon. So it means m times g times h equal half mv squared. Now we are going to find speed of about 20 meter per second. It means we are going to find phi. So if phi is the subject, if phi is the subject, this formula becomes 2 times mg h over m. Okay, and m divided by m equal phi equal square root of 2 times g times h. It's going to be 2 times g is 9.8 into an 8 times h is 28. H is 28. So phi equals uh, square root of 548.98. 89. I will check first. 2 times. Okay. 548.89. And the result is, I have checked on my calculator, the result is 23.42, or rounded to 23. And the unit is meter per second. An air resistance force F acts on the ball. F can be modeled by F equals k phi squared, where phi is the speed or velocity, and k is a constant. Doesn't mean the unit of k in terms of fundamental units. Right. 1 Newton equals 1 kilogram meter per second square. That is 1 Newton. Force has unit is Newton. That is the unit of force. It means one of force equal 1 kilogram meter per second square. That is force. While velocity has unit meter per second. Okay. According to this information, that F equal k phi squared. If we are going to determine k, it means we have to arrange this formula becomes k is the subject. If k is the subject, it means k equal F over phi squared. Now substitute this information into this formula. F is 1 kilogram meter per second squared over V equal 1 meter per second power meter per second. V squared, it means square this. It's going to be K equal uh, kilogram meter per second squared over meter squared second squared power minus 2. Divided equal 1, and it is kilogram over meter, or kilogram meter power minus 1. So K equal kg meter power minus 1. Describe how the ball reaches terminal speed. This is my explanation I have provided. The ball reaches terminal speed when the upward force due to a resistance becomes equal to the downward gravitational force. At this point, the ball stops accelerating and continues to fall at a constant speed. This speed is known as the terminal velocity and is determined, and it is determined by the mass of the ball, the air resistance constant, and the gravitational acceleration. You may add your sentences, your words, as your opinion for this explanation. The graph shows the variations with time t of the speed v of the ball from the instant it is released until it impacts the ground. This is the graph. The vertical axis is for velocity and the unit meter per second, while the horizontally axis is time and the unit is second. State the value of the area under the curve. Area under the curve, actually that is displacement. Okay, so how we determine displacement? Let we look this graph. This graph, this graph, uh, and this graph, constant from 3, okay, when t equal 3 until this is 3.6. So as long as 3 to 3.6, it is constant. And it occurs when velocity is 1, this is 9.5. That means how we determine displacement equal this one, 3.0 times 9.5, and it is 28.5 rounded to 29 meters, the unit. Next, determine K. To determine K, we need several information that at the terminal velocity, force of air, okay, force of air resistance equal force of the gravitational force. Okay, this is important for us. According to the information that F air equal kv squared, and we know that force of gravitational force is m times g. This is W, weight. So based on this information, we can state this inside the box that Kv squared equal m times g. Okay. Now, we are going to figure out k. So it means k equal m times g over v squared. Now, uh, k we can determine m is 2.7 times 10 power minus 3. This is the mass times 9.81. This is the gravitational force over 9.5 squared. That is the speed. Why 9.5? Because on graph, if you look on this graph, that 9.5 is the terminal velocity. Okay. Yeah, so the terminal velocity occur on 9.5. You can check here. 9.5. The terminal velocity occurs on this one. During 3 to 3.6. Let's we continue with our calculation. So K equal, I have calculated this. So the result is 0.2934 times 10 power minus 3. So in significant figures, 2.9 times 10 power minus 3. The unit is meters. According to this part, the unit is in this one. Kilogram per meter. K is kilogram. Okay. Kg m power minus 1. That is K. Number 2. Cruise ice of mass 35 grams at temperature minus 10 degrees Celsius is placed in a warm room. The graph shows the variations of the temperature T of the ice with time T. This is the graph. The specific heat capacity of ice is 2100 joule per kilograms per Kelvin. Show that the average rate at which thermal energy is being transferred into the ice is about 3 watts. The formula for determine thermal energy is Q equal M times C times delta T. But I would like to identify MC delta T. M is mass, mass of the ice is 35 grams. 35 grams convert to kilograms becomes 0.035 kg. C is this one, the specific heat capacity of ice. This is the number. And delta T, we have to convert from Celsius to Kelvin because the specific heat capacity, uh, the this is on Kelvin, not on Celsius. Okay. The temperature. Uh, no, zero degrees Celsius equal 273, 273.15. Yeah, 273.15 Kelvin. while minus 10 degrees Celsius, it is equivalent with 263.15 Kelvin. I have checked this one. So the temperature, if you look on this graph, 0 to minus 10. So it means 0 minus 10 in Celsius. But if we convert in Kelvin, it becomes 273.15 minus 263.15, and it is 10 Kelvin. Okay, so the temperature 10 Kelvin. Now we're going to substitute this information into this formula. Q equal M is 0.03 kg times this one, 2100 joule over kg over K, delta T 10 K. So K. Now I have calculated this, and the result is 735 joule. Now we are going to uh, determine, we will figure out the average rate, the average rate, yeah, the average rate of power. So it means power, or yeah, the average of power. The formula is Q over delta T, 735 joule over 4 times. I'm going to show you on this graph. From minus 10 to 0, look, there are 1, 2, 3, 4. Okay, 4. Okay, 4 minutes, it means 4 times 60. 60 per second is. So the result is, I have calculated this, 3.0625 watts. In a significant figure, 3.1, 3.1, to 0.6 watts. Estimate the specific latent heat of fusion of ice. That, right. The total thermal energy required to melt is, the formula is Q. I would like to Q melt. Q melt. Well, the name is Q melt, is power times T. Time T when melting. P is this one, but I would like to using this number 3.0625 times, there are 60, if you look on graph, there are 60 minutes times 60, convert into second. And so it's going to be, if you calculate the result, wait, I will calculate on my calculator. 11,025, or it is 1.10 times 10 power 1, 2, 3, 4. Okay, joule. Now, specific latent heat of fusion, the formula is L. Okay, the symbol is L. L fusion. I would like to L fusion equal Q melting over M. This is the formula. Q melting is 1.10 times 10 power 4 joule over M is just now 0. Let me see the mass. I forgot mass. This one 0.035 kg. And I will calculate, wait on my calculator. Okay, 1.1 times this one. 3.1, yeah, times 10 power 5. 3.1 times 10 power 5 joule kg power minus 1. Next, between 4 minutes and 64 minutes, solid ice and liquid water coexist at 0 degrees Celsius. Compare and contrast. During this time, the internal energy of solid ice to that of an equal mass of liquid water. I have provided my opinion, my explanation about it. The internal energy of liquid water at 0 degrees Celsius is greater than the internal energy of solid ice at 0 degrees Celsius due to the greater kinetic energy of the molecules in the liquid phase, more freedom of movement, and also the lower potential energy in the liquid phase due to weaker hydrogen bonding compared to the solid phase. This is my opinion. You may add with your words or with your sentence. Number three, outline what is meant by a traveling wave. I have provided my explanation about this. A traveling wave is indeed the transfer propagations of energy, momentum, and information through a medium or space. The loudspeaker emits sound of frequency 210 Hertz into a pipe with one open and one closed end. Okay. The diagram shows a representations of the standing wave established in the pipe. So the length of the pipe is 1.20 meters. Outline how the standing wave is formed in the pipe. Right, before I continue, okay, I will show you my explanation about this question first. The standing wave is formed due to the interference of the incident and reflected sound waves with the closed end of the pipe creating a node and open end creating an antinode. The length of the pipe determines the wavelength of the standing wave and the fundamental frequency, 210 Hz. It matches the conditions for this wave to form in the pipe. Next, determine the wavelength of the wave, right? The first I will I will explain about this wave. Okay, this is actually not one wave because the wave only this from this point to this point. This is half wave. And from this point to this point, or from this point to this point, that is 1/4. Okay. a quarter. So half plus a quarter is 2 over 4 plus 1 over 4, 3 over 4. Okay, 3 over 4 wave. So determine the wavelength of the wave. Uh, Lambda, the formula is lambda equal L over uh, L over 4, yeah, 3 over 4 because wavelength is, the wave is, that one is 3 over 4 wave according to my calculation list. So it's gonna be 4L over 3. L is 120, 4 times 120 over 3. And the result is 1.60 meters. Calculate the speed of sound in the pipe, stating the answer to an appropriate number of significant figures. Right, I'm going to using this formula that velocity or speed equal frequency times lambda. Okay, frequency is 210 and lambda as we calculate 1.60. And if you calculate, the result is 336 meter per second. The solid line represents the standing wave at time t, and the dot line represents the standing wave at an instant later. This is the dot p. The dot is the equilibrium positions of a particle p in the pipe. Equilibrium position. The up arrow indicates the displacement to the right, and the down arrow displacement to the left. Okay. On the diagram, draw a dot to indicate the approximate positions of P at time t. Okay, so we need to find the equilibrium position. When the dot on equilibrium position, when the dot on equilibrium position here at the midline, this is the equilibrium position. Okay, so the dot position, uh, position of P at time t, P is this dot positions at according to equilibrium position. An arrow, and as well draw an arrow to indicate the velocity of P, the velocity at time t, the velocity direction to the left, the direction to the left. Number 4, the diagram shows a junction in a circuit. The circuit, this with junction. The currents in the three wires are related. I1 equal I2 plus I3 given in this circuit. State the fundamental law of physics from which the relations is derived. Okay, so I have provided my answer, my explanation. This one. The relations of I1, this equal I2 plus I3 at junction, wait, at the junction, I have to, what is it? Okay. The relations of I1 equal I2 plus I3 at the junctions in the circuit, is the junction, is derived from the conservations of electric charge and is formalized through Kirchhoff's current law. Okay, I think clear. B. A cell of electromotive force 1.50 volt and internal resistance R, so R is the internal resistance, is connected to a resistor of resistance 5 ohms and ideal voltmeter V. This is the circuit. The reading of the voltmeter is 1.2 volts. Determine the internal resistance R of the cell. Okay. So to determine the internal resistance, we can use the formula derived from the relationship of EMF, electromotive force, and the terminal voltage and the circuit. And the formula is V term. I'd like to using V term. V term, it means V terminal velocity equal EMF epsilon minus I times R, current times internal resistor, okay, which EMF is 1.5 volts, 1.50, and then R or external, this is external resistor, R is 5.00 ohms, and V terminal velocity 1.2 volts. Okay. As well, the current in the circuit can be found using using Ohm's law for the total circuit. Ohm's law and for the total circuit says that I equal EMF over external resistor plus internal resistor. Now substitute this equation into this equation. So V terminal velocity equal epsilon minus epsilon over R plus R times R. Or I would like to continue here that V terminal velocity equal epsilon times epsilon minus R over R plus R times epsilon, like that. And I would like to factorize and divide, becomes V terminal velocity over epsilon equal 1 minus R over R plus R. Or it's gonna be, if one move here, becomes minus V term over epsilon plus 1 equal R over R plus R. And it means minus V term, minus V terms, 1 is epsilon over epsilon, V term plus epsilon over epsilon, R over R plus R. And after that, substitute this information. Substitute this number into this equation, becomes minus 1.5. Sorry, minus 1.2 V term. This one minus 1.2 plus 1.5 over epsilon is 1.5 equal R over 5 plus R. This is 0.3 over 1.5 equal R over 5 plus R. So it means this is 0.3 over 1.5 is 1 over 5. R over 5 plus R. Now multiply this. If multiply, it becomes 1 plus 1 over 5. R equal R. Or uh, R minus 1 over 5. R equal 1. 5 minus 1, 4 equal 1. So R equal 1 times 5 over 4. It is 1.25. And the unit is ohm. A second 5 ohms resistor is connected in parallel to the first resistor, this the circuit. When a second ohms resistor connected in this circuit. State and explain the charge. State and explain the change, if any, in the voltmeter reading without further calculation. Without calculation, we are going to explain. I have prepared my explanation this. When the second 5 ohms resistor connected in parallel to the first 5 ohms resistor, the voltmeter reading will decrease slightly. This is because the total resistance in the circuit decreases, leading to an increase in current. So potential difference across R increases. I'm going to add my explanation, my my explanations uh, my about this explanation that for 2 ohms resistor in parallel, that the R total or resistance total of two 5 ohms equal 5 times 5 ohms times 5 ohms over 5 plus 5 ohms. And the result is 25 over 10. This. And it is 2.5 ohms. 2.5 ohms, 2.5 ohms is, if you compare uh, with with those resistor 5 ohms, this is lower, 2.5 lower than the resistor. Okay, the first resistor and the second resistor. The this resistor are 5 ohms, while this one only are total only 2.5 ohms. So the effect on current, the implication on current, first the implication on current formula is epsilon over uh, R total. Okay, if the R total uh, 2.5 lower than 5, the implications I or current will be increased. That's for current. The implication for voltage. The voltage formula is epsilon minus I times R. If if I increase The implication, the terminal voltage, is if I increase, the terminal voltage will be decreased. Okay. If I increase, because this number will be increased as well. And the implication for potential difference across R, the potential difference across R, uh, the 5 ohms resistor will be the potential difference will be decreased. I mean the potential difference across R. Potential difference across R would be decreased. I think this is clear. C. Proton moves on a circular path in a region of uniform magnetic field of magnetic flux density B that is directed into the plane of the page. It is the proton with the circular path as a circle. On the diagram, draw an arrow to indicate the velocity of the proton at the position shown. This one. Okay. The magnetic force in proton that is always perpendicular to the velocity of this proton. And the velocity is the tangential of the circle for every point. So uh, it means the arrow, okay, the arrow is to downwards perpendicular and okay like this. The direction to downward. Next, show that the frequency of revolution of the proton is given by F equal EB over 2 pi MP, right? I will explain about this. The magnetic force, I would like to use in this area first. The magnetic force, or FB, on the proton. So FB is the magnetic force. This magnetic force on this proton, I need to using this diagram, proton, uh, because of the magnetic field, we can express as FB. If FB is the is a symbol of magnetic force, that FB equal E times V times B. E is the proton charge. V is the velocity of this proton. Okay, while B is this magnetic flux. Okay, and the flux magnetic. Okay, and then the centripetal force F. Okay, the centripetal force required to keep the proton moving on the circular path. It has radius. With the radius, if this is the center of this circle, if the radius, we can express that F, the centripetal force, equal mp. This is mass of proton times v squared. This is the velocity of proton over r. R is the radius. radius of this path, the circular path of proton. So next, when the magnetic provides the centripetal force, we can combine with between this F dash force becomes F equals F. Here, FB equals F, or magnetic force equal uh, the centripetal force. It means we are going to writing E phi B times E phi B equal MP times phi squared over R. We are going to determine F. So it means to determine F, we need to find R, or radius. So if radius is the subject, this formula we can rearrange becomes MP times V squared over E times V times B. Divide and becomes MP times V over E times B. Yeah, that is the radius. Next, the proton moves on a circle. When this proton moves on the circle, it means the distance the distance from the initial point until it returns to the initial point, that is one circumference. And one circumference formula is 2 times pi times r. Okay, so wait. One circumference, uh, if we calculate the time taken to complete one circumference, wait, I still need this information. If we would like to calculate time taken for one circumference, we can use the formula that T equal one circumference over velocity. This is the formula to calculate time taken for uh, one circumference. Next, one circumference formula is 2 pi times r. So it means 2 pi times r over velocity, right? So it means we can substitute this into wait, yeah, substitute not this r into this formula. I would like to writing here. So equal t equal 2 pi r over v. We're going to substitute this fraction into this r. It's going to be mp v over e b over v. So it becomes mp v over eb times 1 over v. Divide. Okay, so it's going to be mp over e times b. Right. To find frequency or f equal 1 over t. Okay, so it becomes 1 over this fraction, mp over eb, or ep over mp. Now prove that F equal EB over over MP. I forgot that is 2 pi, supposed to be 2 pi here. Wait, pi here. I forgot to add 2 pi. This is 2 pi. This is 2 pi as well. This is 2 pi. It means 2 pi here. Wait, I'm gonna fix it. So EB over 2 pi MP. Okay. This is frequency, same like this one. A probe of mass M has landed on the equator of a rotating asteroid of mass M and radius R. This is the probe landed on this uh, asteroid. Okay. The asteroid rotates with angular speed omega. By drawing a free body diagram for the probe, show that the normal force N on the probe from the asteroid is given by N equal M Gm over R squared minus omega squared R. Right. I will start with information that I will I will say that the probe is actually the probe is subject to the gravitational attraction of asteroid, which is given by the formula I'm going to writing here that F gravitational force. This I mean is G times M over R squared. So the direction on this uh, diagram is to the left. Okay, I'm gonna writing Gm M over R squared. G is gravitational constant. M M is mass of the asteroid, and this M mass of probe, and R is radius of asteroid. Next, the centrifugal force, I'm going to scroll down. The centrifugal force is given because there is a centrifugal force also acting on the asteroid. So the centrifugal force is given by M times omega squared times R. So actually the normal force working on to the right, okay, like this is for the normal force. The normal force must balance the sum of the gravitational force and centrifugal force. So we have the equation for the normal force. I'm going to write here the normal force equal F gravitational force minus F centrifugal. Okay, this is the F gravitational force, and this is the F centrifugal. So we can writing here that normal equal G M over R squared minus M omega squared R. Right. So I'm going to factorize that N equal M Gm over r squared minus omega squared r. This the formula of the normal force. Another probe orbits the sun. Oh, there is another probe. The distance between the probe and the sun is 4 times the distance between the Earth and the sun. Okay. Show that the intensity of the solar radiations at the surface of the probe is 85, 85 watts per meter square. Okay. So I'm going to using this formula. Intensity of probe over intensity of Earth. Intensity of probe has formula P over 4 pi times 4d squared over intensity of Earth has formula P over 4 pi d squared, right? It will be 1 over 1 over 16. If we derive this formula, it becomes P over 4 pi P over 4 pi times 16. I'm going to write 16 d squared times 4 pi d squared over p. Okay, so 1. Look, that's 1 over 16. 1 over 16 here. So intensity of probe over intensity of Earth is equal 1 over 16. Next, intensity of probe over intensity of Earth uh, is 1,360. 16, sorry, equal is equal. And then intensity of probe equal 1 over 16 times 1,360. And it equal 85 watts per meter squared. Estimate the equilibrium temperature of the probe, assuming it behaves as a black body. So we are going to find temperature. Symbol is T, the temperature. The temperature unit is in Kelvin. I will using this formula sigma T power 4 equal I. This is the formula how we determine temperature for this case. If T is the subject, it means it is T equal I over sigma power 1 over 4. Sigma is the Stefan Boltzmann constant number. Sigma equal 5.67 times 10 power minus 8. Okay, so it's going to be I is 85. So I 85 over this number, 6 times 10 power minus 8. And if you divide 85 divided by this number, you can find the result 196.7 rounded to 200. And in the significant figures, you have to write in 2 times 10 power 2, 2 times 10 squared. Kelvin, the unit is in Kelvin. Number 6. Quarks are elementary particles. State what is meant by an elementary particle. I have provided my explanations about this question. An elementary particle is a fundamental particle that is not made up of smaller constituents or subparticles. It is considered a basic building block of matter. It means uh, it cannot be divided or it cannot broken down into the simple particles anymore. So that's my understanding about the elementary particle. Next, list the fundamental forces that act on quark. There are four: element, electromagnetic force, gravitational force, strong force, and weak force. Next, the lambda baryon has quark content of UDS. U is up quark, D is down quark, and S is string quark. In the case according to the reaction, this is the reaction. This is the initial state, and this one is the final state. So this is the initial. The reaction becomes proton from lambda baryon, becomes proton and pion. The quark content of the pion is antiquark, antiquark, up quark, and then down quark. State and explain which fundamental interactions is responsible for this decay. Right. If you evaluate this this reaction, this initial state becomes the final state from lambda baryon becomes becomes proton plus pion. That if we compare, I would like uh, to state that the first before we taking the summary or the conclusion that one of the string quark, one of S, okay, one of S in lambda baryon, this is the symbol of lambda baryon, it transform it transform into up quark. It transform into up quark. And the second is this process or this reaction or this process produce this process produce a a W a boson, okay, a W minus boson, which which subsequently 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 decay into a D. D is down quark and this one this one D, so becomes D down quark, and this one anti quark, okay, becomes N anti quark, yeah, and A anti quark. It means one anti quark, one down quark, and one anti quark. and one antiquark. So through this information, my conclusion is uh, this reaction, this decay reaction, this decay reaction is mediated mediated by the weak reaction, the weak reaction, sorry, the weak reaction. Why? Uh, because because it involves it involves flavor changing process from strings quark being up quark, uh, which is which is which is a hallmark. This is a hallmark of the weak force. This one, yeah, flavor changing process. By reference to the concept of binding energy, explain why the combined mass of the nucleons of a nucleus is greater than the mass of the nucleus. I have provided also my explanation about it. So there are several information before my conclusion. The first, binding energy is the energy that holds the nucleons together within the nucleus, or the energy required to break the nucleus into its individual protons and neutrons. The second, according to the Einstein mass energy equivalence principle, the formula is this one: energy and mass are interchangeable. It means that the binding energy of the nucleons also has corresponding mass. The third, the mass defect is the difference between the mass of the individual nucleons when free and the mass of the nucleus. When the nucleons come together to form a nucleus, they release energy in the form of binding energy. This release of energy results in a decrease in mass. And the fourth information, the mass of the nucleus is less than the sum of the individual masses of the protons and neutrons because some of the mass has been converted into binding energy. So based on that information, that's four information, my summary. So the binding energy reduce the total mass of the nucleus compared to the sum of the masses of the individual nucleons. Therefore, why the combined mass of the nucleons is greater than the mass of the nucleus itself. Next. The following binding energies per nucleons are available. It's one: thorium, radium, helium. Determine the energy release in the decay. It's one. So this is This is uh, this the decay reaction actually. From thorium becomes radium and helium. Right. So now to gain the energy release or Q, the energy release is uh, the process from this is energy release minus the binding energy product. So binding energy product is thorium and the energy release is radium and helium. Now we are going to calculate that. Uh, the energy release, radium, 224 times this one times 224 times 1 plus helium 4 1 on minus now this one times this one 228 times 7.6 on. And if you calculate, the result is 5 point, result is 5 point, I have calculated this 5.52, 5.520 microelectron volts. That is the result.